Greetings. I'm Raisul Hasan Shahrukh, and my co-authors are Muhammad Tabassinur Rahman and Dr. Nafees Mansoor. Our paper ID is 34, and the paper title is Exploration of Hyperledger Besu in Designing Private Blockchain-Based Financial Distribution Systems. We are very delighted to be a part of the 11th International Conference on Informatics, Electronics and Vision, ICIEV 2023, and we hope for a successful event. Mismanagement of financial aid is a very common issue seen in governments or organizations across the globe. Funds do get allocated for development or specific aid, but at the end, bad distribution and a lack of accountability and traceability make it difficult for eligible candidates to make claims for their funds. The hassle of claiming pension can be a prime example of the issue. So the problem we have is a lack of media that allows an automated distribution process of financial aid directly to its peers without any interference. Thus, we came up with Aid Nexus with a few objectives in mind to allow time efficient, accurate, and convenient financial distribution through a blockchain empowered fintech application that utilizes Hyperledger Besu, which will minimize handler intervention in aid claims. Our proposed system is very straightforward. Whenever the organization wants to send money directly to its peer, the transaction block will interact with our smart contract and the block will be broadcasted in the private Hyperledger Besu network. A validated block within the private Hyperledger Besu network will validate the transaction and add it to the blockchain. Thus, the peer will receive the money. Our approach to building this system started with research within similar systems, and we found leads for further research. After studying a significant number of research papers, we came up with a comparative study table that compares those existing systems characteristics to get an idea of how our system's characteristics should be in order for it to be robust and user friendly. We would like to state a few technical terms such as throughput, latency, and send rate. The TPS refers to the number of transactions a blockchain network can process per second. Latency is the time taken from when a transaction is submitted until it's added to the blockchain, and send rate refers to the rate at which transactions are being submitted to the network. And it's an external factor determined by the users of the network that were the basis for the existing system's performance analysis. After our finding, we derived the basic functionalities of our system. Only the organization will be able to send funds, add recipients, add funds, check recipient validity and information as it's a private application. Next is a few technical schematics. As the figure states, this is the component diagram of our proposed system Aid Nexus. Every module will be communicating through a private Hyperledger Besu network that will initiate the smart contract to complete various tasks. The communication diagram also states the flow of the communications. We can also understand that the technical design allows seamless integration of the functionalities that will make a private application more robust. Upon implementation, the proposed system will ensure peer-to-peer money transfer through an automated organization that will ensure traceability and accountability of funds. Our custom-made smart contract, which is the heart of the proposed system, has 6 functionalities and an initiator function which makes the process of the task completion robust and maintains traceability as each time the smart contract is initiated, the user will be able to perform only one task. Each time a task is performed, it will leave a footprint in the network and in the form of a block that will hold the information of the tasks that were completed, and the bank account transactions will be encrypted information as the smart contract utilizes KCHAC 256 encoding. This is the demo of our smart contract in the initial stages. After we deploy the smart contract, the functionalities will be visible and we can see that each time the system will create a block that is visible on Etherscan, ensuring it's traceable. However, this is a public network test, but the main goal was to test the integrity of our smart contract. As we can see that we are able to test all the functionalities of our smart contract. Making sure that all of the smart contracts functionalities work was a crucial step in our development, as we had to implement our smart contract further within a private network. So before we went to the private network implementation, we wanted to ensure that there will be no more double work required and no more changes required in the smart contract. One more honorable mention we would like to make is we found out that the Hyperledger Besu doesn't utilize the latest version of Solidity. That's why we had to ensure that we rewrite our smart contract according to the version it was supported. Currently, it supports up to 0.6.0 version of the Solidity. Hyperledger Besu doesn't recognize anything further. So you can see that this is the Hyperledger Besu private deployment. We have further used this network, test network, to deploy our smart contract, and this ensures that we are successfully able to initialize our smart contract within the private Hyperledger based network, which uses IBFT 2.0 consensus algorithm. And we believe that AidNexus has the potential to revolutionize financial distributions through its traceable and accountable nature. Thank you.